So here we wish to look at equations that involve two absolute value functions. So in particular, the absolute value of something is equal to the absolute value of another thing. So we want to think about what this might mean and the different combinations of equations that we could create out of this one equation. So I'm going to return to thinking about absolute value of numbers first, just to get a sense of what might be happening if we have an absolute value equal to another absolute value. So let's think about the absolute value of 3. So obviously if that's going to be equal to the absolute value of something else, it could be equal to the absolute value of 3. So if we have two absolute values equal to each other, that could be because the two things inside them are in fact equal. So in this case 9 minus 4x is equal to 2x minus 3. The other thing though that could be happening is if the modulus of 3 is equal to the modulus of something else, that something else could be negative 3. So what could be going on here is that one expression could be the negative of the other expression, and then when we take the modulus of both of them, they would still give the same result. So we could have here that 9 minus 4x is equal to the negative of 2x minus 3. Obviously we could reverse that statement as well and say that the negative of 9 minus 4x is equal to 2x minus 3, but it's the same equation at the end of the day, whether if you multiply both sides of the equation by negative 1. The other option, if we think about, well, we could argue that negative modulus of 3 is equal to the negative modulus of 3, but these are in fact the same idea. The fact that the thing inside the modulus function has to be, inside the two modulus functions have to be equal. So we could write down the negative of 9 minus 4x is equal to the negative of 2x minus 3, but multiplying both sides by negative 1 will still just tell us that 9 minus 4x equals 2x minus 3. So essentially the result is two equations. So this one equation can be broken up into 9 minus 4x being equal to 2x minus 3, or 9 minus 4x being equal to the negative of 2x minus 3. So now we just have two equations to solve. So if we add 4x to both sides, so 9 equals 6x minus 3. Add 3 to both sides, so 12 equals 6x, and divide both sides by 6, so x equals 2 is one solution. And the second equation, I'll expand out the negative on the right hand side, so 9 minus 4x is equal to negative 2x plus 3. If we add 4x to both sides, so 9 equals 2x plus 3. Subtract 3 from both sides, and divide both sides by 2. So we find that we get two solutions, and we can check that these solutions are true. If x equals 2, the left-hand side will be 9 minus 4 times 2, so 9 minus 8, so 1. Modulus of 1 is 1. And the right-hand side will be 2 times 2, which is 4, minus 3, which is 1. Modulus of 1 is 1. If x is equal to 3, we're going to have the modulus of 9 minus 12, so the modulus of negative 3 on the left-hand side, which is 3. And on the right-hand side, we'll have the modulus of 6 minus 3, so the modulus of 3, which is also 3. So both are valid solutions to this equation. Let's have a look at a second example. So modulus of 2x plus 5 equals the modulus of 2x minus 1. So we know from our previous examination that this is going to produce two equations. Either the two things inside the modulus signs are equal, so 2x plus 5 is equal to 2x minus 1, or one's the negative of the other. So 2x plus 5 is equal to the negative of 2x minus 1. So looking at the first equation, if we subtract 2x from both sides, we can see that we're going to have a bit of a problem. So obviously 5 does not equal negative 1, so this branch produces no solution. Expanding out the right-hand side in the second equation, so 2x plus 5 equals negative 2x plus 1. Adding 2x to both sides. Subtracting 5 from both sides. And dividing both sides by 4 gives negative 1. So here we just get the one solution. We can check that it works. If x is negative 1, On the left-hand side, 2 times negative 1 is negative 2, plus 5 is 3, and the modulus of 3 is 3. On the right-hand side, 2 times negative 1 is negative 2, minus 1 is negative 3, and the modulus of negative 3 is also 3. So x equals negative 1 is a valid solution. When we start to look at the graphs of modulus functions in a bit more detail, you'll start to see why there are some situations where there might only be one point where these two functions intersect, as opposed to other occasions where there might be 2 or 3, as we saw with the example with the quadratic on a previous video. So in conclusion, if we have the modulus of one function equal to the modulus of another function, then one of two things could be happening. Those two functions could actually be equal to each other, or one function could be the negative of the other function.